The table shows the number of hours Felicia spent sleeping each night for 12 nights. Which type of data display would be best for displaying the data? So what we have, our data right here, looks like that we would like to use a line plot as the best one. For number 6, the line plot below shows the number of fiction books read by one 7th grade class. The teacher says the average number of books read is 6.5. Explain how this could be misleading. So we have an outlier of 15, which can throw off our mean and be misleading. Number 7, so the basketball coach says that the average height of his 5 basketball players is 72 inches. Explain how that could be misleading. The heights of the 5 players are in the table below. So we have about 4 players around the 68 to 70 range and one about 85 inches. Therefore, our 85 is our outlier, which can be misleading of our average. For number 1, you want to select an appropriate type of display, then make a display. The data below shows the high temperatures on July 4th. We have the years and the degrees Fahrenheit. So our years are going to be representing our x-axis, and our degrees are going to be representing our y-axis. We are going to want to use a line graph to represent this data. Here I constructed my line graph, starting with the years 08, 09, 10, 11, and 12, and then our temperatures on our y-axis. Once I plotted the data, I connected my data with my lines to complete my line graph. For exercises 2 and 3, use the box plot that shows students' test scores for 2 classrooms. We have room 14 and room 12. Which class had a greater range of scores? So if we look at room 14, we see that they have 100 as their maximum and around 75 for their minimum. Therefore, their range is about 25. For room 12, we see the maximum is about 95 and the minimum is 50. When you subtract those, you get about 45. Therefore, room 12 has a greater range of scores. Number 3 wants you to write an inference you can make about the populations. If you look at their medians, you can see room 14 has a median of around 87, where room 12 has a median around 72. Therefore, you can make an inference that room 14 did better on the test than room 12. For exercise 4 and 5, you need to use the table. It shows the number of students in each extracurricular school club. For number 4, they want you to find the mean, median, and mode of the data. When looking for the median, you start with your biggest and your smallest. So when you move in, you find out that your median is 15. Now looking at mode, when you're looking at your data, it looks like that we have 2 modes. 12 is twice and 15 is twice. So our modes are 12 and 15. To find our mean, you need to add up all of the numbers together. So when you add up all the data, you get 220. You then divide the 220 by 11 because that's how many data points we have. When you do that, your mean is 20. The principal says the average number of students in a club is 20. How could this be misleading? This goes back to talking about the outliers. Our outlier in our data set is 73, which is a lot higher than even the second highest, which is 25. That is what's making our average higher at 20, even though it's not represented well of the data. For number 6, the table shows the ages of actors who starred in a series of movies. Select an appropriate type of display for the data, then make a display. As you can see, we have quite a few data points. When thinking about this, since we have so many, the best bet is probably to use a stem and leaf plot. Here I did my stem and leaf plot right to the right of the data points. As you can see, my 0 category goes from 0 and our 10s, so 10, 20, 30, 40, and 50, and represents our data. For our last problem, they are looking at the number of scores a Panther had following number of points during games this season. So the data below is not in order. So for part A, they want you to order the set of the data from the least to greatest and find what are the minimum and maximum values. Our minimum value is our least number, which is 68. And our maximum is our greatest, which is 96. For part B, they want you to find the median. Explain how you found this value. So I ordered our data above the problem from least to greatest. When you start from the minimum and the maximum and move in each a spot until you get to the middle, we find that our median is between 86 and 86, which means that it is 86. Part C is now looking at the lower quartile, and that is the median of the lower half of the scores. What is the lower quartile of the data? So then we start from median now at 86 and 68, and we go into the middle until we reach our number of 78. For part D, the upper quartile is the median of the upper half of the scores. What is the upper quartile of the data? So now we're looking at our higher half. So we start from 96 and 86, work our way in until we get our median of 89. For part E, they want you to find the difference between the upper quartile and the lower quartile. This difference is called the interquartile range. Therefore, we have 89, subtract 78 from that to end up with 11. 2 is asking, what does the interquartile range represent? It represents the middle 50% of the data. Now for part F, I have a number line below. Above your number line, draw vertical line segments at the values you found for the median, the lower quartile, and the upper quartile. Our median was 86, which I already drew the line in for. Our upper quartile was 89, and our lower quartile was 78. From there, you connect the vertical lines to form a rectangle. For 4, they want you to locate the value you identified as the minimum and draw a line to the left from the rectangle to meet that point. We said that the minimum was 68. So we'll put a dot there and connect it to our box. And finally, for 5, locate the value you identified as the maximum and draw a line to the right from the rectangle that meets. We said that our maximum was 96, so you're going to put a 96 above the number line and connect it. Therefore, we did our box and whisker plot by using the median, the upper quartile median, lower quartile median, and the median in the minimum and maximum.